So recording of the session is started. Now I'm going to take your attendance. Alright, so the attendance is.
अस्सलाम वालेकुम सर।
वालेकुम अस्सलाम।
सर एक स्टूडेंट है 151, उनके दादा बाबू की डेथ हो गई, तो उसकी अटेंडेंस लग सकती है?
ओके, अभी तो वो क्लास में नहीं है।
नो सर।
ओके ठीक है, नेक्स्ट टाइम जब वो क्लास में होगा तो आई टॉक टू द क्लास इन सी, ठीक है?
राइट।
उसको कहें नेक्स्ट जब लैब हो हमारी तो एंड पे वो मुझसे बात करें।
ठीक सर।
Alright, we have 19 attendees. Let's wait for maybe a couple of more minutes and then we will start. Okay, let me see if I can try to share the link here. Okay, 118, I have shared the link here to join the meeting. But I think the best way to join the right meeting, but at times, because I see sometimes some students start a new meeting and when other people try to join in the meeting, they find multiple meetings and that creates confusion. So the best way to come to the right meeting is that you go to your calendar and you will find this meeting in your calendar, because I have scheduled all our classes and I have invited all of you guys in those meetings. So go to your calendar and whatever meeting you see for section C at this time slot, just join that meeting and you will always come to the right meeting, because I do the same. Okay, we have 24 attendees now. We'll start at 8:05. All right, so it's 8:05. Let's start. Let me share my screen. All right, can you guys see me now?
Yes, sir.
Yes, sir.
Okay. So let's start our today's discussion. Today we will be talking about second experiment of this lab, and this experiment is related to the study of small instruments. So title of the experiment that we will be discussing today is study of small instruments. And purpose of this job is to make you guys familiar with different instruments, small instruments that we will be using in future. In our last lab, we talked about the layout of strength of materials lab. and we saw all the big machines that we have in our lab. We will be using some of those machines to perform our experiments. And the purpose of this job is to make you guys familiar with the small handheld instruments that we will be using in future. We will be talking about the ranges of these instruments, their least counts, their scales, what physical quantities do they measure, all these things we will discuss. So that's the objective of our today's job. Now let's switch to, let's start discussing the instruments that we will be talking about. Okay, so the first one is vernier calipers. So this instrument is known as vernier calipers. Okay, let me switch my camera, maybe that might give you a better view. Okay, so can you guys see the vernier calipers on your screen?
Yes, sir.
All right. So the way we will be proceeding with this lab is that first of all, I will give you an overview of all the instruments that we will be discussing. I'll be showing you in the video that what an instrument is, how to use that instrument, and later on we will be reading some sample measurements. I have already uploaded pictures of these instruments on our OneDrive folder. Last night I shared a folder link with you guys on the same team. That folder link will contain all the video lectures that we will be having in this semester, plus any other material that I want to share with you guys, like it may be images or some handouts or whatever that will be present in the same folder. So I don't need to share the link with you guys every time. I will just upload the stuff on the folder and you can download it using the same link. Okay, so this instrument is the first one. It's known, its name is vernier calipers. You guys might have seen that before. And this instrument is used to measure length or internal diameter or external diameter or depth of any container. So whatever dimension we want to measure, or whatever object we want to measure, let's say it's this one, we place it in the jaws like this, and then we have a clamp. We can clamp this reading. Once I tighten you, then the reading gets clamped, and then we can read the measurement on the scale. This vernier caliper has two scale. This scale on, now as I have clamped the reading, so it doesn't matter even if I let this object go because the reading is clamped. So this long one, this is known as main scale, and its range is up to 200 millimeters. And the small scale is known as vernier scale. This vernier scale divides 1 millimeter into 20 equal parts. So the least count of this vernier calipers is 0.05 millimeters. And this vernier calipers can read or it can take measurements in millimeters as well as in inches. So these are some parts of vernier calipers and least count and its range. In a short while, we will see that exactly how to read the any measurement from vernier calipers. We will use the images that I have already shared with you guys. So this was the first one, and in some cases, if you want to measure, let's say, the internal diameter of any object, supposedly, let's say, I want to measure the entire diameter of this cup. How I'll do this? Okay, let me unclamp this, and I will open the vernier calipers equal to this internal side, internal diameter, and for internal diameter measurement, this side of vernier calipers will be used. So I will open it equal to this dimension, and then using the clamp, I can clamp this reading, and then I'll take it out, and now I can read this. How to read this? We are going to talk about that in a short while. At this point, all you need to know is that it has two scales. Main scale, uh, graduated in millimeters as well as in inches, and vernier scale. We have vernier scale, one vernier scale on this side, which is graduated in millimeters, and the other vernier scale on the other side, upper side, and it is graduated in inches. We will be taking all of millimeters and centimeters, so we'll just focus on this side of the main scale. Okay, so this was the first instrument, vernier calipers. All right, now let's move to the second one. The second instrument that we will be talking about is screw gauge. All right, so this instrument is known as screw gauge, and this instrument is used to measure length of any object or thickness or external diameter. The range of this instrument is from 0 to 25 millimeters. It is written here. Yeah, I think now it's visible. So the range is written here as well as least count is written here. The range is from 0 to 25 millimeters and least count is 0.01 millimeters. And this instrument has two scales. One is this linear scale. One is the linear scale on the straight line, and other is circular scale. The linear scale is up to 25 millimeters. Let me just open it up completely so that you guys can see that. So the linear scale is graduated up to 25 millimeters because the range of the instrument is up to 25, and circular scale is further divided into 50 divisions. So that makes like 1 millimeter is divided into it is divided into 100 actually finally. How is that? Because the main scale has two graduations. One graduation is in whole millimeters, it's on the lower side, and the divisions on the upper side of this horizontal line are dividing each millimeter into two equal parts. So the smallest value that we can read from the main scale is 0.5 millimeters, and that 0.5 millimeters is further divided into 50 equal parts using this circular scale. So that makes the least count of this instrument as 0.01 millimeters. And we have a lock here. Let's say you want to measure any dimension. Supposedly you want to measure the diameter of this thing. Let me just bring it close. Okay, so let's say you want to measure the diameter of this marker, and then once it is very close to just clamp the object, then we start using this other screw. This is known as ratchet. What is the purpose of this screw ratchet? It is used to control the compression that we want to apply on this object, because this instrument is very precise. It can measure up to 100th part of a millimeter. So if we apply excessive pressure, that may result in slight compression of the object if the object is a bit flexible, and that will affect the measurement. We don't want to do that. In order to fix this tightening issue, this knob is provided that is known as ratchet, and we finally tighten the this object with the ratchet, and every time it will apply a fixed pressure. So we'll know that there is no excessive pressure on the object and the object is not compressed. That will help us in measuring the exact value of thickness or diameter or length, whatever we want to measure. And this instrument has a lock too. Like right now, for example, I can easily rotate this part, but if I apply this lock and I hold it this way, now even if I try, I cannot rotate this part, and the circular scale is fixed. So once I have known that how much opening is required here, or I have clamped the object, then I can hold this lock here, and that will fix the reading, and then I can conveniently read the values on the linear and the circular scale. So this device is known as screw gauge, and in a short while we will read a couple of readings on this screw gauge. That will give us more clarity about the use of this instrument. Okay, so this was the second one. Let me close it and place it here. Okay, now let's move to the next instrument. The next instrument is known as deflection gauge. For deflection gauge, let me turn on the other camera. All right, so this instrument is known as deflection gauge. As its name indicates, we use this instrument to measure deflection. It has a gauge here, which is graduated in terms of inches, and let's say we have a beam. Now supposedly, if this is a beam, and for this beam I want to measure deflection when I apply load. So what happens when I apply load? It deflects down. So if I want to measure the deflection in the beam, what I'll do, I will place this gauge and beam in such a way that the top end of this needle, wait a second, that the top end of this needle is touching the bottom end of the beam. So when the beam will bend down, this needle or this pin will move in the downward direction. And if you look closely, when the spin moves downwards, the needles on the gauge, these needles rotate. There are actually two needles. If I give you a close up here, there are two needles. One is this big needle and one is small needle. This small needle is actually bigger scale, large scale, because one division of this small needle scale is a lot bigger than the one division of this larger needle. So we have two scales in this gauge. One is large scale, which is apparently smaller in size, and one is a small scale that has this big needle. So whenever we want to measure deflection in any component, we place this device in such a way that this part is in contact with the part that is going to deflect. And when the deflection is there, the spin moves and needles on the gauges on the gauge move. And then we can note down the reading on the main scale and large scale and reading on the small scale. The maximum range of this device is 0.5 inches and the least count is 0.001 inch. This, like all these screws that you see here, you see a knob here and you see a knob on this side and you see one knob here. All these knobs are adjustable. So we can use this instrument in any orientation we want. If we expect the deflection to be downward, we'll place it in this way. So whenever the deflection takes place, the spin moves downwards. If we expect, in some cases, we expect deflection to be upwards, we can rotate this device and we can bring this needle in the downward direction. And when upward deflection will take place, we will be able to measure that using the same instrument. And one cool feature of this device is that the base has the magnetic properties. So whenever we want to measure deflection at any location, we need to fix this device in such a way that it is its position remains perfectly fixed, because if this instrument is moving, it will not be able to measure the deflection precisely because it will have its own displacement, and we do not want that. And for that reason, this magnetic base is provided. Now, let me show you how does it work. We have a steel plate here. This is a steel plate. And right now, if I put this device on this steel plate, you can see that I can easily lift the device off the steel plate. Now, if I give you a closer look, if you see here, there is on and off written on this bottom block. This on and off is about magnetic property of this device. Now let me turn this to on. Now I have turned the magnetic property on. Now let me show you again. Did you hear that sound? Now the bottom of the plate is fixed with the bottom of this device is fixed with the plate because the magnetic action is turned on. So whenever we want to install this instrument, let's say under a beam, so we prepare a platform at the bottom, and on top of the platform we install a steel plate, and then on that steel plate, using this magnetic action, we can fix this device, so that when we are measuring the deflection, this device remains perfectly fixed and it can give us the value of deflection precisely. Now in a short while we will discuss that how to read these scales and get the deflection values. Okay, I see something popping up on my team, so let me see what's that. Okay, I see a couple of hands raised. 115, please go ahead.
Sir, can you please repeat the least count of this device?
Least count. Least count of this device is 0.001 inch.
Okay, sir.
Okay. The images that I have already sent you, all the images have close-up views of these devices. You can see those images. Plus, we are going to discuss those images here in class as well. So we will have a closer look on these scales in the video because the resolution of video is not very good. So you might not be able to see that, but don't worry. I'm going to show all these things to you. Okay.
Yes, sir.
All right. Next is 148. Please go ahead.
सर आपने इस डिवाइस में हमें मैग्नेटिक एक्शन के बारे में बताया था ना, तो सर ये कोई डिजिटल डिवाइस तो नहीं है ना, हम इसमें से एक नॉब को टर्न करते हैं तो उसका मैग्नेटिक एक्शन ऑन कैसे हो जाता है? क्योंकि
it is a mechanical function. I have never seen that how it works, like what's the mechanism inside, but what I expect is that there might be some material in between that is that restricts the magnetic action. Some layer of material may be present, and when you turn the knob on, that layer is removed or something like that. That's just my rough guess. I'm not sure about that, how this magnetic and non-magnetic function works. Actually, I never need to get into that. But this device is surely not digital. It has some mechanical function in it.
Okay, sir. Thank you.
All right. So this was deflection gauge. Now let's move to our next device. Our next device is a dial gauge. Now
So by the deflection, do we mean the distance between the positions that is undeflected and deflected, vertical distance?
In case of beams, normally that's how it is. The undeflected beams are, you may say, the line or longitudinal axis of an undeflected beam is perfectly horizontal, and when you apply loading, the beam sags down and it becomes curved. So whatever is the distance between undeformed shape or undeflected shape and deflected shape, that is termed as deflection.
That is a vertical distance between the centers?
That is vertical distance. Yes, vertical distance between the centers. But this device can be used to measure inclined distances and horizontal distances as well. In case of beams, normally the deflections are vertical, but we might have some other component in which we have some inclined members, maybe some truss element, and some truss element which is present in the vertical plane. It may be inclined or it may be vertical, and in that case, deflection will not be vertical. It might be horizontal. So even if that's the case, we can change the orientation of this device and we can measure the horizontal deflection as well. Okay.
Thank you, sir, about that.
All right. And yes, one more thing. Even in case of beams, sometimes we have horizontal deflections. For example, if this is a beam, let's say, if I apply a vertical load on this beam, it will deflect downward. So the deflection will be vertical. But if under certain condition there is horizontal loading. For example, there are a couple of significant horizontal loads that act on a structure. One is earthquake and second is wind load. These two loads act in the horizontal direction. So if we have a beam and let's say the building is subjected to earthquake loading, so the beam will deflect in horizontal plane. Okay, it will either come out of the plane or it will bend into the plane. And similarly, under the action of wind loading, the deflection will be in the horizontal direction. And this device can be used to measure that horizontal deflection as well. Okay, so next small device that we are going to discuss is this dial gauge.
Sir, I have a question.
Yes, please go ahead.
सर जो लास्ट डिवाइस हमने डिफ्लेक्शन शो की है उसके अंदर वो स्पेसिफिक पॉइंट की सर डिफ्लेक्शन शो करता है. अगर उसको मिड में रखते हैं तो मैक्सिमम डिफ्लेक्शन आएगी. फॉर एग्जांपल अगर बीम को वर्टिकली मतलब लोड दिया जा रहा है, अगर उसको मतलब राइट या लेफ्ट पे कर देंगे तो कंपैरेटिवली वो सेंटर के बनिस्बत कम डिफ्लेक्शन आएगी. तो ये सर ये स्पेसिफिक पॉइंट पे देता है. ये मटेरियल की नेचर तो एग्जैक्टली नहीं बता रहा कि मतलब कितना मटेरियल डिफ्लेक्ट होता है वो बीम.
It gives us deflection at a specific point. Now it depends upon the given problem that what do you want to measure. If you want to measure maximum deflection in case of a simply supported beam that is subjected to, let's say, a point load at the center, the maximum deflection will be at the center and you will install the deflection gauge accordingly. It is not necessary for any structure to or for any beam to have maximum deflection at the center. If the applied loading is has such orientation that the maximum deflection does not occur at the center, so you may install this device at that location where you want to measure the deflection. So it's up to you as an engineer. If you are analyzing a problem, it is your understanding that at which point you want to measure deflection. So wherever you want to measure, you will install the dial gauge. And if your question is that whether it gives us deflection for a particular point or for an entire member, then the answer is that it gives us deflection for a single point. It does not give us deflection for the entire member for all the locations. No. Okay.
Thank you, sir.
All right. So next device is this dial gauge. This dial gauge is used to measure thickness or external diameter or length of small objects. For example, if I have this steel scale and I want to measure the thickness of the steel scale, I can place it like this, and you see when I change the opening of these two components, the needle on the dial gauge moves. So if I want to measure this thickness, I will hold it like this and then I will try to read the scale. Now, unfortunately, this device is not in working condition, so we will not be using this, but still we have this device available. So just as a practice that how to read this and how to establish the least count as well, I thought that it would be better if I show you this device, and in a short while we'll see how this how to read this. This has only one scale and the range is from 0 to 1 inch, and the least count of this instrument is 0.0025 inches. The least count of this device is 0.0025 inch. And as I move this, as I change the opening, the needle on the dial rotates, and then we can read it accordingly. One of the objectives of our today's job is to make you guys understand that how can we see that what is the least count of any instrument. Most of the time it is written on the device. For example, even on this dial gauge, the least count is written. Right now you can see the mirror image. This is 0 to 1 inch and the least count is 0.0025 inch. When we'll see the images, you will see able to see that properly. So one thing that I want you guys to learn is that if I give you an instrument and even if the least count is not written, you guys should be able to judge the least count. If we know that if let's say the total range is written that okay, this total is 1 inch, then you should be able to see that, okay, 1 inch is divided into 10 divisions, and those 10 divisions are further divided into 10 equal parts or 20 equal parts, and that 20th or 10th part is further divided into, let's say, 2 equal parts. So you should be able to read the gauge in that way and establish the least count of the instrument. So this instrument will give us, will help us in developing that understanding. Okay, I see something popped up on my Teams. Let me see if there is any question. Okay, I don't see any hand raised, but there is something in my chat. Okay, we have a couple of questions here. By the deflection of beam, do we mean the vertical distance between undeflected and deflected position of the beam, or any other concept? So I think we already answered this question, that if the beam is horizontal and it is subjected to vertical loading, then yes, we mean the vertical distance between undeformed shape of beam and deformed shape of beam. But the deflection may or may not be vertical in all the cases. It may be horizontal, or even it may be in some inclined plane. Okay, next, 118 is having some internet issues, so the call is disconnecting. Mark my attendance. Okay, this reminds me that I need to take attendance one more time. Let me go back to my meetings. Okay. I'll take the attendance. Meanwhile, 127, please go ahead.
Sir, please clarify the purpose of dial gauge using the dial
Using
gauge.
a dial gauge. Okay. So, dial gauge. This device is dial gauge, right? Now, as I change this, look at this needle. As I change the opening, the needle rotates on the scale. Okay. So if I want to measure, let's say, thickness of this scale, what will I do? I will place it like this, and I will hold it in this position. Now, whatever is reading on the scale, that is giving me thickness. Reading on this dial, that will give me the thickness. So the purpose of this device is to measure thickness or small lengths or outer diameters of objects. Okay, is it clear now?
Yes, sir. Thanks, sir.
All right. So this was dial gauge.
Maximum कितना thickness में ये कर सकती है?
Up to 1 inch. Its range is 1 inch. So it can measure any dimension from 0 to 1 inch, and the least count is 0.0025 inches. So this was dial gauge. Now the next instrument is extensometer. This device is known as extensometer. When we will be performing tension test, we will use this device. What this device is used for, this is used to measure extension, elongation, or shortening in any steel bar or any similar type of testing specimen. It can measure elongation as well as shortening, but in our case, we will be using it to measure elongation. Now, let me show you this using the other camera. All right, so I see something on my team, so let me just check that out. Okay, there's something in the chat. Record the lecture so we can watch it later on. Okay, yeah, that's fine. Zen, we are already recording the session, and this recording will be available to you. So don't worry about that. All right. So let's come back to the camera view. This device is known as extensometer. This device has two scales. One is a small needle. This small needle is basically the large scale, and this large needle is basically small scale. Why we call this large needle as small scale? Because the value of one division of this scale, this bigger looking scale, is actually much smaller than the one division of this or this part, this lower part, these two lower parts of the device, you see, these parts are movable. We can either open them or we can, okay, this. Can you guys see this opening as I move it? You see this opening is increasing and this is decreasing. So what we do, let's say we have a steel bar, and for that steel bar we want to measure elongation. We will actually be doing this. How we'll do that? We will place the steel bar. Let me just open this. So we'll place the steel bar here. Can you guys see this marker moving? Right. So we'll place the steel bar here, and then we will clamp it using these two clamps. These two components. We will clamp the steel bar, or in other words, we will clamp this extensometer on the steel bar. And when we apply, let's say, tensile load, we try to elongate the steel bar. This extensometer will open like this. You see, as I move these black components, just look at this component. As I move this component inwards or outwards, then the needles on the gauge, these needles move. Okay, these needles move. So this instrument can measure elongation as well as shortening in any dimension. And reading of this instrument is a bit tricky because as it can measure both the phenomena's elongation as well as shortening, and when it elongates, the needle moves in counterclockwise direction, but when it shortens, the needle moves in clockwise direction. So for the same instrument, we have movement of this needle in two directions. That is what makes reading this instrument a bit tricky. I have uploaded a couple of images of the readings, and I will show it. I will discuss that with you guys when I'll show you those images. Because in this view, it's not easier to read this. But right now, what you need to know is that the extensometer, its range is 5 millimeters and its least count is 0.001 millimeters. And it has two scales. Large scale, the least count of large scale is 0.2 millimeters, and the least count of the small scale is maybe you just need to know the least count of this instrument as a whole, that is 0.001 millimeter. So just keep that thing in your mind. Okay, now how to read this, we'll discuss that in a short while. We will be using this instrument while performing tension test. So this was extensometer. After extensometer, now let's move to some other small instruments which are very simple ones. Let me switch the camera. All right, so there are some other simple instruments that we will be using. Okay, there is something on my Teams. Okay, any question? Anyone? Everybody's clear about this?
Yes, sir.
Okay,
Yes,
let me
sir.
see. There is something in the chat. Okay, where will you upload these images? These images, 290, these images are already uploaded on my OneDrive folder. And last night I shared the link of my OneDrive folder with you guys. It is in the conversation, general conversation of this team. So you guys would be, even right now, you guys can access that because you have the link in the general conversation of this team, and from that conversation you can get the link and go to the folder, and the images are there. And right after discussing these instruments briefly, I will show you these images here on my screen, and we will be talking about those measurements in detail. Okay. All right. So there are some other simple instruments that we will be using, including the steel ruler. This steel ruler is graduated in terms of inches as well as millimeters. Right now, it is probably not that convenient to observe this. The resolution is not good, and plus you see mirror image of the scale. So the image is already with you, and I will show you that image in a short while. Okay, it is graduated in terms of inches as well as in millimeters. In inches, it can measure up to 1/64th part of an inch, and in millimeters, it can measure up to 0.5 millimeters. The range of the scale is, in terms of centimeters, it is 30 centimeters, and in terms of inches, it is 12 inches. So there is nothing complicated about this scale. Then we have some other simple instruments. For example, this one is known as spring divider. Now, what a spring divider is used to divide any given length into certain number of portions. You guys would have already used this in civil engineering drawing. There is another use of the spring divider whenever we want to measure any length and we don't have any other instrument available. So what we do, using these tips of spring dividers, we open the spring divider equal to that distance. And let's say there is, okay, let me switch the camera. Okay, let's say there is any object that I want to measure. Let me give you an example. Supposedly, I just want to see how much is this dimension of vernier caliper. Let's say I don't have any other instrument, so I can just open this spring divider exactly equal to this dimension. Okay, I just open it exactly equal to this dimension, and then I can use the scale. I will put this on a scale, and then I can read it either in terms of inches or in terms of millimeters. So this is how we use a spring divider. When we will perform tension test, initially we will be measuring the elongation of steel bar using using extensometer, but at later stages we will have to use spring divider, and then you will become more clear about this. So this device is known as a spring divider. Next we have another device that is known as inside calipers. This device is known as inside calipers, and this is used to measure the internal diameter of any object. In case of spring divider as well as for this inside caliper, we have this screw available that helps us in opening this inside caliper with good control. Now let's say we want to measure the inside diameter of this cup. What can I do? I can just open this gradually exactly equal to, okay, it's not clear in this view. Okay, now you guys can see that. So I'll just open the spring divider equal to the internal diameter of, okay, let me see, it's closing, equal to the internal diameter of this cup. And using this knob, I can do this quite accurately. And once it is opened exactly equal to this diameter, this inside diameter, I'll take this device out and I'll put it on some steel rule, and I'll read that how much is this dimension. So that will help us in measuring the internal diameter of this cup. And spring divider and this instrument inside caliper, these instruments do not have any scale, so they don't have any least count or precision level. it all depends upon the steel rule that you are using later on to measure this opening, right? So this device is known as inside calipers. After this, we have another device that is known as outside calipers. Let me switch the camera view. All right. So this device is known as outside calipers. It is used to measure outside diameter and lengths of any object. Just like inside caliper and spring divider, it has this lever and screw available. So with this, we can control the opening quite precisely. See, I unscrew this and then it opens up to this level and it remains fixed here. Supposedly, I want to measure the external diameter of this mug. How to do that? Let me use the other camera to show that. Okay, if I want to measure the external dimension, how I'll do this? I will open this equal to the external diameter. Here, I have opened it equal to the external diameter, and using this screw here, I can convince the caliper is opened exactly according to my requirement. I can just take this out and then I can put this thing on a steel rule and I can measure this opening. So that will help us in measuring the diameter of this object, outer diameter of this object precisely. So this instrument is known as a outside calipers. So this is outside calipers, okay? And again, it does not have any scale, so it doesn't have any least count. It all depends upon the steel rule that you are using to finally measure its dimensions, its opening. Okay, so these were the small instruments that we have in our lab, and we will be using most of them in the experiments that we will perform in future. This was the brief description. Now, next step is to learn how to take readings from these devices. For that, I have taken the images of some measurements, and we will discuss those measurements one by one. So before starting that, anybody having any question at this point? If you have any question, raise your hand. Okay, I don't see any hand raised. Okay, Usman Raza, please go ahead.
सर जो डिफ्लेक्शन गेज है
Yes.
सर वो जब हम इनिशियल में जब शुरू में बीम वगैरह कंस्ट्रक्ट करते हैं उसी वक्त उसके साथ फिक्स कर देते हैं उसको
No, this deflection gauge will not be a permanent component of the structure. We will install it underneath a beam at the time when we want to measure deflection. But we do, in some cases, we have to perform experiments like load tests. Now, what do we mean by a load test? A load test means that you have an existing structure and you want to determine its capacity. So what we do for that, let me turn on the camera. What we do, supposedly we have this beam and we decide that, okay, we want to perform load test for this beam and we are going to actually load this beam. So before starting putting the load on this member, we install a deflection gauge at the bottom and then we apply load, and whatever deflection takes place afterwards, that is recorded by the deflection gauge. Okay, so we do not install these deflection gauges like be ready for it. No, that's not the case. In some cases, if we want to
सर ने आई थिंक मीटिंग ही लीव कर दी है।
Okay, guys, can you hear me now?
Yes.
Yes sir, we can.
Yes, sir.
Okay, so I'm having some connection issues. Right now, I have joined the meeting from my mobile, but all the data that I want to share with you guys is on my laptop. So just give me a few minutes. I hope should be fine, and I will be able to connect through my laptop. All right, so my connection is restored. Okay, can you guys hear me now?
Yes, sir.
Yes, sir.
Okay, that's great. So I am reconnected using my laptop now. Now I can share this stuff. All right, so as I said that I will be showing you the images of these devices, and we will be learning how to read these, how to read measurements from these devices in detail. So let's start with that. Okay, let me share my screen. Okay, can you guys see the image of a vernier caliper?
Yes,
Yes,
sir.
sir.
So this is the image of a vernier caliper, and you guys have already seen this. It has main scale, vernier scale, etc. We have already talked about that. So this image, this complete image is for your lab reports. In your lab report, when you will be describing vernier calipers, you will show this image. Now let's take a couple of examples. Okay, I see a question. Let me take that question. Okay, while measuring external diameter using internal diameter instrument, there are many risks to get a chord instead of a complete diameter. As chord is smaller than diameter, how can we avoid this risk? In this case, okay, one thing is that at the beginning, as you mentioned, while measuring external diameter using internal diameter instrument, we will not be doing that. If we want to measure internal diameter, we will use inside caliper. External diameter, we will use outside calipers. But even then, the or that uncertainty is there. So we will have to take the reading cautiously. That's the only thing I can suggest. It depends upon the judgment and care of the person who is using the device. These inside caliper, outside calipers, these are not like sophisticated instruments. And if you want some measurement like really precise, then preferably you should not use them. But in some cases, we need relatively crude measurements. Only in those cases we use these devices. Okay, 132, is it clear?
Okay, sir.
All right, so now let's move to the images again. This is the image of entire okay, there is something on my Teams again. A lot of unread messages. Okay, so somebody said let's have a break. Should we finish this or should we have a break? You guys want to have a break?
Finish it. So finish it kindly.
Finish it. Okay, 118 is suggesting finish it. It's gonna take some time, but I think we already had a break. My connection was lost, so no problem. We can just go ahead. All right, so this is a close-up view of a reading. Now, how to read vernier calipers? Vernier scale, this is vernier scale and this is main scale. Can you guys see the arrow, my cursor on my screen?
Yes, sir. We can see.
Okay, that is great. So this is 0 of vernier scale. Whenever you want to read any reading from vernier calipers, you need to see that how many readings on the main scale are present prior to the 0 of vernier scale. So in this case, this is 10 millimeters, 11, 12, 13, 14. So the main scale reading in this case is 14. I would suggest you guys to have a copy and pen with you and keep on noting this stuff. So I have numbered the images. So this is image number 2. And for image number 2, you can record that what is the measurements that we are reading from this instrument. So the main scale reading in this case is 14. And how to read the vernier scale reading? Vernier scale reading is for that we need to see that which division of vernier scale is coinciding with any division of main scale. So starting from 0, we'll just keep on looking that which division of vernier scale is coinciding with any division of main scale. Is there any problem with the connection? Arsalan is waiting in the lobby. CR, are you here? CR? CR? Okay, the CR is not here. But anyways, I think the people, the students who have to wait in the lobby are the ones who have not joined Teams with their official email IDs. Otherwise, if you have an official email ID, then you can just directly come to the meeting. You don't have to wait in the lobby or need my permission. So make sure that you have given me your official email ID. Then it will be more smooth. Okay, let's come back to the reading. So in this case, our main scale reading is 14 millimeter, and the vernier scale reading, I think this line, which is present in between the graduation 7 and 8, is perfectly coinciding with some line of main scale. In this case, we are not concerned that which line of the main scale, we are concerned that which line of the vernier scale is coinciding with any line of main scale. Okay, any connectivity issue? Okay, Wasim. Wasim? Okay, Wasim, are you here now? Wasim? Wasim, I have just allowed you in the meeting. Can you hear me?
जी सर.
Okay, Wasim, have you registered with through your official email ID?
जी सर. सर मुझे मेल नहीं आई थी, इसलिए नहीं सर पता लगा.
Okay, so you are joining like now.
जी सर.
That's not good. The class starts at 8 a.m. I have already marked the attendance. Anyways, it's up to you.
जी सर.
All right. Now, so the main scale reading is 14 millimeter, and vernier scale, we have just observed that this line is coinciding with any line of the main scale. Now, this line is present in between the lines on which 7 and 8 is written, and we see that alternate lines are marked on this, like graduated. So the line with which 2 is written is actually 4th line. We will not count the 0 line. We'll start from here. 1, 2, 3, 4. So the line on which 2 is written is 4th line. Similarly, the line on which 7 is written is basically 14th line. And this line will be then 15th line. So vernier scale reading is 15. Main scale reading is 14 and vernier scale reading is 15. So how to get now, as this is our first reading, so let me write it down in the chat box. Main scale reading is equal to 14. Vernier scale reading is equal to 15. Why main scale reading is 14? Because the 0 of vernier scale is ahead of 14th division of the main scale. That's why it's 14. And so the 14 full millimeters are there. And vernier scale reading is 15 because the 15th line of the vernier scale is coinciding with any division of the main scale. Now the measurement will be equal to 14 plus 15 into 0.05, and that will make 14.75 millimeters. Can you guys see my messages in the chat? I have shown
Yes, sir.
how to take the measurement. Main scale reading is 14, vernier scale reading is 15, and measurement is 14. 14 is the main scale reading. You don't need to multiply it with anything, with least count or anything. Only vernier scale reading will be multiplied with the least count. So 15 is the vernier scale reading into 0.05 is the least count, and the sum of these two terms will give us 14.75 millimeters. So this reading shown in this picture right now is 14.75 millimeters. Is everybody clear about this? If you are not clear about this,
Yes.
please raise your
Yes,
hand.
sir, we are clear about.
Okay, that is great. Now, in this case, if you read, okay, yes, Usman, please go ahead.
सर ये मेंस के रीडिंग बता दें जरा 14 किस तरह लिया हमने
Look at the vernier scale 0. How many divisions of main scale are present prior to the 0 of vernier scale? Read the main scale. 1, 2, 3, 4, 5. This is 5th line. Then up to here, this is the 10th line, means 10 millimeters.
Okay.
11, 12, 13, and 14. So 14 lines of main scale are present prior to the 0 of vernier scale. That's why main scale reading is 14.
Okay, sir.
All right.
सर हम इधर 14 की बजाय 15 भी तो ले सकते थे, वो भी तो इसका करीब है 14 के ये दरमियान में ही है 0, यानी 14 और 15
0 is at the center. That is actually we want a precise reading. We do not want to make an approximation. That is why we are using vernier scale. If we did not want to make a precise reading, we would have not used vernier calipers. We can, using an ordinary scale, we could have said that this reading is 15 millimeters and that's it. The purpose of using vernier calipers is to get a precise reading, a more precise reading. Making an approximation is not something that we want in this case. If it was allowed, we would have simply used a steel rule and we would have said that, okay, this dimension is 15 millimeters. Okay, we want a precise measurement. Is that clear?
जी सर.
Okay, now coming back to our readings. In this case, what we did, we read the main scale separately, then the vernier scale, and then we used calculator to add 14 plus 15 into 0.05, and that gave us 14.75. But there is a more direct way available to read this value. Let me show you how. Quickly, you can see that this reading, main scale reading is 14. And then if you come to the vernier scale, if any line on which the number is written, let's say if this line on which 7 is written, if this line had been coinciding with any line of the main scale, we would have directly said that the reading is 14.70. And if the line in between 7 and 8 is coinciding with any division of main scale, for example, in this case, as it is joining, we can directly say that the reading is 14.75. 14 is coming from the main scale and 0.75 is coming from the vernier scale. 14.75, 0.5, because this is the line present in between 7 and 8 is coinciding with any division of main scale. If this line had been coinciding, we would have said that it is 14.70. If this line had been coinciding, we would have said this is 14.80 and so on. So this is a way to directly read from vernier calipers. Okay, is there any question? I see something on my Teams. Okay, there is no hand raised. All right, so this is how we read vernier calipers. Everybody is clear about this?
Yes, sir.
Sir.
Okay. Okay, that's great. So now let's move to our next instrument. Oh, before I have actually provided two pictures of every instrument. So this is the second image of vernier caliper. Now let's try to read this directly without using any calculators or anything. So anyone, how much is the main scale reading? Look at the zero of vernier scale. How many divisions of main
41.
scale?
41.
41. That is
41,
right.
sir.
Main, very good. So main scale reading is 41. And which division of vernier scale is perfectly coinciding with any division of main scale? If we start
17.
from this,
16.
16
Sir,
is this one.
Mid between 8 and 9.
Mid
17
between
is
8
no,
and
sir.
9. Right. So the one that is present at the center of center of 8 and 9, this is 17th. So either we can do this 17 into 0.05 and then we add 41 into it, or can anybody directly tell me the value?
41.85.
Exactly, 41.85. That's good. So without using any calculator, we can just by looking at the instrument, we can directly tell that how much is the reading. So 41 is the main scale reading, and the line between 8 and 9 is coinciding perfectly with the main scale reading division. So it is 41.85 millimeters, and that is it. Everybody's clear about this? Everyone, keep your mic mute. I'll mute it. Okay, so I think we are good with vernier calipers. Now let's move to our next instrument, that is screw gauge. We have already discussed different components of screw gauge. Yes, yes.
सर प्लीज उसका जीरो एरर एक बार बता दें.
Yes, zero error. I actually checked these instruments and there was no zero error. But if we have to see that, okay, I see a message. 807, okay, 119. I took an attendance afterwards as well, but make sure that in future you join at 8 o'clock sharp, because I'm keeping track of these things. I want all of you guys exactly on time. Okay, zero error. In some of the cases, for example, if I go back here, when we close the instrument, then the zero of vernier scale and the zero of main scale, they are not exactly coinciding with each other. If they are not exactly coinciding with each other, it means that there is zero error in the instrument. So whatever is the reading on the instrument, considering the main scale reading and vernier scale reading, we read that. Let's say in that case, the reading comes out to be 0.2 millimeters, supposedly. So if 0.2 millimeters is the reading, when you have completely closed the jaws of this instrument, then 0.2 millimeters is the zero error. And zero error may be positive or negative. If it is measuring extra 0.2 millimeters, then we will say that the error is positive and correction will be negative. By positive error, I mean that every time it will be measuring 0.2 millimeters extra. So let's say any measurement comes out to be 10.8 millimeters. So from that 10.8 millimeters, I need to subtract 0.2 millimeters. So when error is positive, the correction and vice versa is also true. Okay. So when error is positive, it means that the instrument is measuring more than the actual measurement. And every time we have to subtract that from our measurement. Okay. Is there any message or? Okay. It's not still added. Okay. There is a message from another class. All right, so this was something about zero error. Is it clear?
Yes, sir.
Okay, so now let's move on to screw gauge. We have already discussed what a screw gauge is. Right now it is not fully closed. Okay, let's see some measurement. On this linear scale, we have lines at the bottom. This line is showing 1 millimeter. So this is 1 millimeter, 2 millimeter, 3, 4, 5 millimeter. And the line above, the lines above this horizontal lines are dividing each millimeter into 2 equal parts. So this is 0, this is 0.5, 1 millimeter, 1.5, 2 millimeters, 2.5, and so on. So if we read this accordingly, the current reading on the main scale is how much?
5.5.
5.5. That's right. So the current reading on the linear scale or main scale is 5.5 millimeters. So main scale reading is 5.5. Then what about the circular scale reading? For circular scale reading, we will see that which division of circular scale is coinciding with any division of with this horizontal line. What is that?
15.
That is 15 in this case. So the measurement in this case is 5.5 plus 15 into the least count. How much is the least count of this device? Least count is 0.01 millimeter. We can see that written here. So 5.5 plus, okay, if I write it down in the chat. Now I will not write down separately that this is main scale and this is circular scale. So 5.5 plus 15 into 0.01, and that gives us what? It gives us 5.65 millimeters. So 5.5 plus 15 into 0.01, this gives us 5.65 millimeters. So this much is the current reading on the scale. Everybody is clear about this?
Yes.
Okay. Now let's see another reading, another example. How much is the linear scale reading in this case? 5, 10,
11.
11. And the other division on the upper side is not like visible. We are probably getting a shadow of it, but it's not completely there. So we will say the main scale reading is 11, or the linear scale reading is 11. How much is the circular scale reading?
32.
32.
32. So 11 plus 32, and 32 will be multiplied with the least count, that is 0.01. So the value will be 11.32 millimeters, right? So the current reading on screw gauge is 11.32 millimeters. Everybody is clear about this?
Yes, sir.
Yes, sir.
Okay, that is great. If you have any question at any point, just raise your hand. Okay, so with this, now let's move to our next instrument, that is deflection gauge. This is picture of the complete instrument.
Excuse me, sir.
You will be pasting it in your, yes.
सर ये स्क्रू गेज में जो जीरो एरर होगा उसके बारे में थोड़ा सा बता दें. पॉजिटिव तब होगा जब सर्कुलर स्केल की रीडिंग आगे होगी.
Is or one thing is that the
सर जी आपकी आवाज नहीं आ रही.
Okay, I see a message that my voice is not clear. Okay, I think there is some connectivity issue on my end. We still need to go over 3 more instruments. I think at this point probably we can have a break. Let's see if this connectivity also gets fixed. And we will start after 10 minutes. So I'm just stopping the meeting here. We'll start again at 9:31 a.m. Okay, but be clear that our recording is on. Uh, whatever between us, that will be recorded. So I'm just muting my mic at this point. We'll start at 9:31 again. Okay, guys, it's 9:31 a.m. Can you guys hear me?
Yes, sir.
Okay, that's great. So let's come back to our discussion about small instruments. We have seen vernier calipers and screw gauge till this point. The next instrument is deflection gauge. I think that what is a deflection gauge and how this is used. This is a picture of the complete instrument. Let's have a closer look. Some of the readings. So of the dial of deflection to move in inwards direction as well as in outwards direction. So whenever we are reading these such instruments that in which the pin or the measuring device can move in both the, it is important for us to know that in which direction the needle is currently moving. Okay, everyone can see this because I see some connectivity issues at my end. Everyone can see the dial gauge picture.
Yes, sir.
Yes,
We can.
sir.
Yes, sir.
Okay, okay, that's great. All right. So in case of dial gauge, if the dial, let me come back to the previous picture. If the dial gauge is installed in this orientation, then the pin is at the top. When the pin moves in the downward direction, the needle of dial gauge rotates in, deflection gauge rotates in clockwise direction. Such instruments in which there is provision of movement of needle in both the direction. In those instruments, while reading the observation from the instrument, you need to keep that thing in your mind, that whether the needle is rotating in clockwise direction or it is rotating in counterclockwise direction. In our case, when we will be using this instrument, I think in all the cases we will be measuring vertical deflection, and we will be using the instrument in this orientation. So in our case, the needle will be rotating in clockwise direction because this pin will be moving in downward direction. So if the pin is moving, this pin is moving in the downward direction and the needle is rotating in the clockwise direction, let's see how to read any value on the gauge. Okay, the range of this gauge is 0.5 inches, 0.5 inch, and the least count is 0.001 inch. This small needle is actually representing a bigger scale, and each division of the scale is equal to 0.1 millimeters. If I zoom in further, so this is 0.1 inch, sorry, not millimeters, inches. This is 0.2 inch, 0.3 inch, 0.5 inch. So how much is the large scale reading currently? Large scale reading is 0.2 inch because the needle is ahead of 0.2. So large scale reading is 0.2 inch. And what about the small scale reading? In order to see the small scale reading, you need to know that what is the direction of rotation. 0 is here. If the needle is in clockwise direction, then we read it as 10, 20, 30. But if you know that the needle, for a given measurement, the needle is moving in counterclockwise direction, then you will read it like this. 10 will be in this direction, 10, 20, 30, 40, 50, 60, 70, and 80. So the same location of needle can give you two different values considering the direction of rotation. If it is rotating in clockwise direction, the current reading is 25. If it is reading in counterclockwise direction, the current reading is 75. So while reading deflection gauge, you need to know rotation. So before taking measurement, you see that, okay, आवाज कट रही है मेरी? Yes, I see some connectivity issues. although the signals appear to be full. Is it better now? Can you guys hear me now? Is it better?
Yes, sir. It's better now.
Yeah.
Yes, sir.
Because that warning is gone now. I don't see that warning on my screen anymore. Okay. So, where was I was telling you that while measuring with
सर
such
वॉइस कट हो रही है.
वॉइस कट हो रही है. Okay. Let me switch the network. All right, I have switched the network and the warning about the bad connection is not there. Is it better now? Can you guys hear me now?
Yes, sir. Now we can hear.
Yes, sir.
Okay, that's great. So let's move. So the needle of the dial can rotate in both the directions, clockwise as well as counterclockwise. We need to see this thing beforehand, before taking the measurement, that whether the needle is rotating clockwise or counterclockwise. So in this case, if the needle rotates in clockwise direction, the current reading would be 25. But if it is rotating in counterclockwise direction, the same location of the needle will give us a reading of 75 millimeters. Okay, so the main scale or the large scale reading is 0.2 and small scale reading is 25. Okay, so the current reading, let me write it down in the chat box. The current reading would be 0.2 plus 25 into 0.001, and that is equal to 0.225 inches. Okay, it's the level. So can you guys see the reading that I've just written in the chat box? 0.2 is the large scale reading, 25 is the small scale reading, and small scale reading is multiplied with the least count. So 0.2 plus 25 into 0.001 gives us 0.225 inch. Everybody is clear about this?
Yes, sir.
Yes, sir.
Okay, that's great. So let's see one more reading for deflection gauge.
Sir.
Yes.
Sir, for
Okay,
large scale
290,
reading,
please go ahead.
Sir,
Sorry?
where 0.2 from?
No. 290, not understand what did you say. Would you please repeat?
Sir, where 0.2 is from?
0.2? Oh, 0.2, let me go back to the image. 0.2 is from this scale, this one. 0.1, 0.2, and you can see that this needle is ahead of 0.2 and it is prior to, it is before 0.3. So it is showing that our actual measurement is somewhere in between 0.2 inch to 0.3 inch. So 0.2 inch is the main scale reading, and how much more than 0.2 inch, that comes from this small scale, which is bigger than scale.
Are you right?
Is it clear? 0?
I got it.
Okay, Usman, please go ahead. Okay. Yes, Usman.
सर बस ये कंफ्यूजन थी, मैं कह रहा था कि 2 से थोड़ा सा आगे है, तो वो वाली रीडिंग हमें ये जो स्मॉल स्केल रीडिंग है वो यही देती है कि ये 2 से कितना आगे है?
Exactly. Yes.
Okay, sir.
All right. So let's move to another reading of deflection gauge. Here is a close-up view of another reading. And again, I tell you that in this case, the needle was rotating in clockwise direction. Okay, so how much is the large scale reading in this case? 1, 0.2,
0.35.
The needle is
0.35.
exactly. So 0.3 is the large scale. Okay, good. 0.3 inch is the large scale reading. What is the small scale reading?
30.
The needle is rotating in clockwise direction, so it is 30. It's very close to 30, just a little bit before 30, so we can take it 30. Okay, so in this case we can use our judgment. So it's close to 30, so the small scale reading is 30. So can anybody tell me how much is the final value? 0.3 is the main large scale reading and 30 is the small scale reading.
3.030.
So how much is the total reading?
3.030.
0.330 actually. This look at the least count. Least count is 0.001 inch. It means that we can only go up to third decimal place. We cannot measure 0.3030. We cannot measure that much from the scale. Okay, so 0.3 plus 2.001, that will give us 0.330. Yeah, somebody written this in chat. That is correct. 0.330 is the current value of reading using this deflection gauge. Okay. Any question?
सर जब ये डिफ्लेक्शन एंटी क्लॉकवाइज होगी तो लार्ज स्केल की रीडिंग भी हमने एंटी क्लॉकवाइज ही लेनी है या स्मॉल स्केल की रीडिंग भी एंटी क्लॉकवाइज लेनी है या उसको क्लॉकवाइज ही लेना है?
In that case, even that would, what will happen? Even in that case, the needle will start, we will have to adjust it accordingly, and even the large scale will be rotating in clockwise direction, counterclockwise direction. So let's say the initial reading in that case you set at 0.5, and when the needle is moving in counterclockwise direction and it comes to 0.4, you will read it as 0.1 inch. Okay. So although the scale will show you that this is 0.4, but you will read that as 0.1.
Okay, sir. Thank you.
I will explain this point when we will come to extensometer as well, because we have the similar issue in extensometer as well. And in extensometer, we will be reading it in counterclockwise direction. So just give me a few minutes. We will be clear about this other direction reading as well. Okay, next is the dial gauge. So this instrument is known as dial gauge, and let me give you one reading of dial gauge. There is only one scale in case of dial gauge, and if the dial gauge is working properly at 0, it will be here, and for 1 inch, it will complete 1 revolution and it will come back here. Range is from 0 to 1 inch, least count is 0.0025 inches. So this large graduation is 0.1, 0.2, 0.3, 0.4, and so on. So this one is 0.8. So our current value is ahead of 0.8. This is 0.8, and from this point to this point, this is 0.1. See, this is 0.8, this line, and this line is 0.9. It means this distance is 0.1 inch. So if this is 0.1 inch, this 0.1 inch is further divided into 2 parts using this big line. So it means that this is 0.05 inch. From this point to this point is 0.05 inch. And that 0.05 is further divided into 5 parts using these lines. This line, the line under needle here and needle here. So this one is further dividing it 0.05 into 5 equal parts. So from this point to this point is 0.01 inch. From this point to this point is 0.01 inch, and this 0.01 inch is further divided into two parts using this line. So this 0.05 inch divided by 0.001 inch is further divided into two parts with this line, that becomes 0.005. So for the distance between this line, big line, and this line is 0.005 inch, and that is further divided into two equal parts using these outer lines. So finally we get the least count as 0.0025 inch. So the least count of this device is 0.0025 inch. Now how to read this? The current value 0.8 and 0.81, 0.82, 0.83. So the current value, if I zoom it in further, the current value is 0.8300, I would say. Now there may be some disagreement in this. Some person may say that, oh, it is coinciding with the outer line, so it is 0.8325, but I think this is closer to 0.830, but this much judgment is allowed. I can say 0.8300. Some of you might say that this is 0.8325, but that is fine because it's kind of in between, so we can use our personal judgment in this case. I have shown this one reading for this device because this device is not in working condition and we will not be using it. Okay, clear about this?
Yes, sir.
All right, so I don't see any hand raised, so I think this is fine. All right, now with this, let's move to our last instrument, that is extensometer. So here is picture of the complete instrument. We have again two scales. One is physically small needle, but this is bigger scale, and other is a small scale. Right now both the scales are exactly at 0. Here I have given you a closer look of 0, 0 reading for this case. The range of this instrument is 5 millimeter. The maximum reading that it can take is 5 millimeters, and least count is 0.001 millimeter. So each graduation on the main scale, you can see that 0, 1, 2, 3, 4, and this will be 5. So these lines are of 1, 2 millimeters, and then 1 millimeter is further divided into 5 equal parts. So you see here 1, 2, 3, 4, 5. So which means that the smallest reading that we can read from this large scale is 0.2 millimeters. The smallest reading that can be read on this scale is 0.2 millimeters. And then if you look at the small scale, starting from 0, it is, if you look at the graduation in both the direction, in counterclockwise direction 10, 20, 30, and in clockwise direction we have 10, 20, 30, and so on. Again, before taking the measurements, we need to know that when we will be measuring our physical quantity, whether the needle will be rotating in clockwise direction or counterclockwise direction. So the way the scale has been designed, this instrument has been designed, when the this instrument is measuring elongation, mean the jaws of, or the opening, the needle in this direction, and when it is measuring contraction, it moves.
सर आपकी आवाज नहीं आ रही, कट कट के आ रही है।
सर इसे रिपीट कर दें।
Okay, guys, I'm back. Sorry, I was having some connectivity issues. Okay, can you guys hear me now?
Yes, sir.
Yes, sir.
Okay. Okay. Let's hope the things are made fine. All right. So, can you guys see my screen? The dial gauge, extensometer gauge.
No, sir.
No,
No.
sir.
Okay. Let me share it again. Okay. Let me share it. All right. Can you see that now?
Yes, sir.
Yes, sir.
All right. Okay. So we have now. I was telling you that this needle can rotate in clockwise as well as in counterclockwise direction. And when the instrument will be measuring elongation, the needle will rotate in counterclockwise direction. And when the needle will move in, when the instrument will be measuring contraction or shortening, the needle will move in clockwise direction. In our case, we will always be using this instrument to measure elongation. That's why I have chosen two examples of elongation measurement because that's the relevant case for us. Now, as I have told you beforehand that both the needles are moving in counterclockwise direction. So let's see how to read the large scale first. If you look at the graduations, 0, 1, 2, 3, these graduations have been made in such a way that if the needle is rotating in clockwise direction, they will give you the reading exactly whatever is written on the scale. But if it's in counterclockwise direction, then you have to just read it more carefully because the value shown on the scale is not like you cannot read it directly. You'll have to make some conversion. So if it's moving counterclockwise direction, this is 0.2. 0.4, 0.6, 0.8 and 1 millimeter. And this value is 1.2 millimeters. Now, why we are reading like this? Because I have told you beforehand that these graduations, okay, can't understand clearly. Voice is distorted. Let me see. What is my Teams showing?
It's clear now.
It's clear now? Okay, yes, because I don't see any warning on my screen. All right. So needles are moving in counterclockwise direction. So we have to read it sort of manually, like 0.2, 1, 0.4, 0.6, 0.8, 1 millimeter and 1.2 millimeter. So the needle of large scale is ahead of 1.2 millimeters. So the large scale reading in this case is 1.2. And what about the small scale reading? This is 0 and the needle is moving in counterclockwise direction. 10, 20, 30, 40, here up to here. This is 85. So the small scale reading is 85. So what will be the measurement? Let me write it down in the chat box. The measurement in this case will be 1.2 plus 85 to 0.001 and this is equal to 1.285 millimeter.
Repeat.
Okay. Repeat. Okay, I'm going to repeat. Okay, I have posted the reading in the chat box. Now, let's come back to the gauge again. So, as the needles, both the needles are moving in counterclockwise direction, so we will have to okay, guys, the my power went off, so everything is kind of restarted now. What I want you guys to do is, because now I'm not on my system, I will be just finishing it off on my mobile phone. Can you guys hear me?
Yes, sir.
Yes.
Okay, so I have already uploaded these pictures, and I have shown you the one of the readings as well. So how did we do that? If you look at the needle on the large scale, I want you guys to go to the link and that I have shared last night and open these images there. Some of you might have already done that. Right now I cannot show those images on my screen now, so I'll be just explaining it verbally. How did we get our main scale reading? In our chat box, you can see that I have written the measurement. The first value is 1.2. How did we get that? We move in the counterclockwise direction on the large scale, and every small division is equal to 0.2 millimeters. So 0.2, 0.4, 0.6, 0.8, 1, and then 1.2. The needle is ahead of 1.2. So the large scale reading is 1.2, and then on the small scale, if you read the reading in the counterclockwise direction, the reading is 85. Okay, so the reading is 85, and 85 will be multiplied with the least count 0.001, and ultimately you will get 1.285 millimeters. Is everybody clear about this?
Yes, sir.
Okay. All right, so we have seen how to read the extensometer now. In the data that I have uploaded in the images, there is another image of extensometer. When you will, if you are in a position to see that right now, just see that image, or you can watch that, see that image later on. I can explain that what reading is there. When you will read that, again, that reading has been taken for a case when the needle was moving in counterclockwise direction. So I can tell you the reading and then you will read it by yourself. The main scale reading in that case is equal to 3 millimeters exactly. It is the large scale needle is ahead of 3 millimeters. So you will read it as 3. And again, you will have to read it indirectly because the scale is graduated in the clockwise direction, but the needle is reading in moving in counterclockwise direction. And similarly for small scale reading, once you reach 100th division, after that you will have to read in the opposite direction. So the reading that is shown in that image, the small scale reading is 117. I want you guys to check that by yourself right now or later on, that the reading of small scale in the second image of extensometer is 117. And 117 will be further multiplied with the least count, 0.001. And finally, you will get a reading of 3.117 millimeters. So I want you guys to check that out by yourself. And if you guys have any problem with that, we can talk about that in next class. Okay. So this was the last instrument that we need to discuss today. Other instruments that we talked about, like spring divider, inside caliper, outside caliper, those instruments do not have any scale on them. They do not require any detailed discussion. We have discussed all the instruments that have scale on them in the end. I hope this is clear to you. If you guys have any question, please let me know. If you have any question, raise your hand. Okay, Wasim, please go ahead.
सर मेरा चैट बॉक्स नहीं सर ओपन हो रहा.
चैट बॉक्स ओपन नहीं हो रहा
जी, वो कह रहे हैं कि मेंबर नहीं है मेरा ख्याल आप सर टीम मीटिंग टीम के.
आप मेंबर नहीं है, but if you are in the meeting, then you are surely a member. Have you used your official ID or unofficial ID?
ऑफिशियल आईडी सर.
Official ID. Okay, that's a bit surprising because sometimes students face these difficulties when they use unofficial ID. Okay, I hope if you just get out of the meeting and rejoin it, this problem might be fixed. But for today, our discussion is actually concluding. Hopefully, in the next meeting, we will not face this difficulty. I have sometimes myself experienced some weird issues, but in such cases, I normally leave the meeting and rejoin, and such abnormalities just get fixed by themselves. Okay.
और सर मुझे मेल भी नहीं आई इस लेक्चर की आज.
Okay, just do one thing. On your Teams, there is a tab for calendar.
जी.
Open that tab. I have added your entire class and scheduled a meeting on the calendar. Okay. So
जी sir.
every time, can you see that?
सर आपकी आवाज कट के आ रही है.
मेरी आवाज कट के आ रही है. Okay. I hope it gets better because signal is fine at my end. But anyways, on the calendar, there is a calendar tab. If you go into that calendar tab, you will see a meeting scheduled by me and you are invited in that meeting. So whenever you want to come to the class, go to the calendar and at the class time, you will find a meeting. I have already scheduled the meeting, this lab meeting for the entire semester.
Okay, sir.
You always use that calendar link to come to the meeting. You will always come to the right place. Okay?
Ji sir.
All right. So anybody else? Any other question? Wasim, if you are done, lower your hand. Okay.
सर एक्सटेंसोमीटर.
Yes.
सर एक्सटेंसोमीटर के अंदर वो अगर रीडिंग क्लॉकवाइज डायरेक्शन में आएगी तो इसका मीन ये है कि वो लेंथ जो है वो कंप्रेस हो रही है, शॉर्टन हो रही है.
Yes.
अब अगर वो काउंटर क्लॉकवाइज में आएगी तो इसका मतलब वो एक्सटेंड कर रही है.
Yes.
थैंक यू सर, बस यही पूछना था.
All right. So now with this, let's talk about your manual. What do I want in your manual? As I discussed this earlier, that we will be, you are allowed to have composed manuals or handwritten manuals. So in your manuals, I want the problem statement, purpose of this job, and images of all these instruments and the images with the readings. So image and its reading. I want all that information in your manual. And whatever you can, when you will put the entire picture of the entire instrument, you will label that. Okay, this is main scale, this is vernier scale, this is a clamping screw, something like that. So whatever components we have talked about, you will label those components and the use of the instrument. So I want all these all this information in your manual. And for your Viva Voice preparation, I want all you guys to be able to read these instruments. We have discussed all these devices in detail. So I want all you guys to be capable of reading these instruments. Okay? Everybody's clear about this?
Yes, sir.
All right.
Sir, please एक दफा दोबारा बता दें sir, lab manual का.
Lab manual. In your lab manual, you will write down the problem title, the job title, purpose of this job that I described at the very beginning, and pictures of all these instruments, picture of the complete instrument, and pictures of the readings that I have shared. And on the reading picture, you will write down the, like on the picture or underneath the picture, you will write down the reading shown on that, in that picture. Like if it's a close-up view of a vernier caliper reading, you will write down how much is that reading. And for your Viva Voice examination, you should be able to read all these devices. In your Viva, I might ask you that, okay, I open the vernier caliper and I ask you that, okay, read it. How much is this? All right. So you should be prepared for that. Is it clear?
Yes, sir.
Yes, sir.
All right. That is great. So I think with this, we can conclude our discussion today. The video of this meeting, our today's meeting, will hopefully be uploaded soon on on the same folder whose link is already with you guys. So I'll just leave the meeting now. Allah Hafiz.